So today, we're tackling a massive shift that's happening right beneath our feet and, honestly, literally right in front of our eyes. We're talking about the heavy civil machinery that builds our cities, our roads, our transit systems. For decades, this industry has just been completely synonymous with the roar of diesel engines and those heavy exhaust plumes. But the ground is shifting toward a much more sustainable, fossil-free future, and it is absolutely fascinating to see how the technology is finally catching up to the ambition.
Now, I want to hook you immediately with this number, 98%. No way, right? But back in 2018, Volvo Construction Equipment and Skanska ran an electric site research project at a quarry in Sweden. By electrifying each transport stage and using autonomous battery electric load carriers, they achieved a staggering 98% reduction in carbon emissions. A 98% drop, that's not just a slight improvement. It proved that massive fundamental disruption in heavy civil machinery isn't just a pipe dream, it's entirely possible, and it's already happening.
Okay, let's dive into this. First, we'll cover electrifying the construction industry, followed by a look at the Volvo EC230. Then, we'll break down Skanska's Los Angeles pilot, slash some emissions and costs, dive into a better operator experience, and finally, forecast the future of heavy machinery.
Section 1. Electrifying the construction industry. A global shift. And this brilliantly illustrates the macro push for sustainability. It's no longer just a talking point, right? It's a pressing need. Companies like Skanska have set these really ambitious targets, like achieving a 70% carbon reduction by 2030. And to actually get there, they have to address the heavy machinery on their sites. When we look at the adoption of battery electric vehicle excavators, there is a very distinct gap between North America and the EMEA region. That's Europe, the Middle East, and Africa. Europe is currently leading the charge, forecasting a much faster penetration of electric machinery over the next decade. American sites have traditionally been a bit slower to adopt those European emissions regulations, but the pressure is definitely mounting. The urgency for the American market to close this gap is real, simply because the environmental and economic benefits are just too massive to ignore.
Moving to Section 2. Meet the Volvo EC230 Electric Innovation. So that brings us to the tangible technological solution bridging this gap, turning those lofty sustainability goals into an actual reality on the dirt. The brilliance of the EC230 electric excavator is that it doesn't try to reinvent the wheel, it just removes the emissions. It's built right on Volvo's already proven traditional crawler excavator technology, meaning it has the heavy lifting power you totally expect. But it brings massive benefits to the table: zero tailpipe emissions, significantly lower noise, and less vibration. And because it uses an electric motor, the hydraulics are incredibly responsive. Plus, from an operational standpoint, that electric motor is practically maintenance-free because it completely eliminates all those traditional diesel engine-related components. It's a real game-changer.
Now, you might be wondering, what's the first question everyone asks about electric heavy machinery? It's, how do you charge it on a job site? Well, the EC230 makes it pretty straightforward. It uses a 240-volt Level 2 alternating current setup, which, believe it or not, is exactly the same setup you'd see on normal road-going electric passenger vehicles. You just need a temporary facility charging station on site. And for operations that need a rapid turnaround, direct current, or DC fast charging is available to drastically reduce those charge times.
Section 3. Skanska's Los Angeles pilot, putting it to the test.
Let's move to and see how this builds, because specs on a page are great, sure, but the true test of heavy machinery is always in the dirt. We're going to look closely at an incredible partnership between Volvo Construction Equipment and Skanska, one of the world's leading project development and construction groups. Let's trace how this tech evolved across a 5-year timeline. As we established, it kicked off in 2018 with that massive electric site research project in Gothenburg, Sweden. Then, fast forward to 2022, Skanska was actively utilizing the EC230 on their fossil-free Slakthus Omeradet project in Stockholm. And then, finally, the technology crossed the Atlantic. In 2023, Skanska launched a rigorous 90-day trial of the EC230 right in the heart of Los Angeles.
Looking at the original 2018 Swedish site, you can really see the sheer ambition of those early phases. I mean, these were massive, custom prototype machines operating in a quarry. It was a research project specifically meant to show what the future could look like. It shows just how far the technology has evolved, maturing from these complex, multi-machine quarry prototypes into commercially viable, mid-sized excavators totally ready for urban American construction sites.
So grounding the story in the specific 2023 Los Angeles pilot, Skanska put the EC230 to work at the south yard of the La Brea station, which is part of the massive Purple Extension Transit project. And let me tell you, this was not a delicate lab test. The goal was to see if a battery-powered excavator could actually perform the necessary heavy-duty construction work of loading trucks with export material from a stockpile, while directly comparing it to its diesel-powered counterpart. And spoiler alert, it kept the pace of work perfectly on schedule. No delays.
Section 4. Slashing emissions and costs, the hard data. Now, keeping the schedule is just a baseline expectation, right? What we really care about are the improvements generated by this 90-day LA pilot. First up, a 66% reduction in carbon emissions per hour. Just think about the sheer scale of a major infrastructure project and what a 2/3 reduction in hourly carbon output actually means for a company's overall climate targets. It's huge.
But wait, it gets better. Beside the environmental win, the pilot yielded a 74% reduction in hourly operational costs. This right here, this is the magic number. It establishes an absolutely undeniable bottom-line economic argument that stands right alongside the environmental one.
So the crucial point is exactly what those percentages mean in raw numbers for a project manager's budget and environmental reporting. Every single hour that the EC320 was running instead of a diesel machine, Skanska saved 34 kilograms of carbon from entering the atmosphere, and they saved an estimated $15.15 in direct operational costs. Multiply that across an 8-hour shift over a 90-day pilot, and then extrapolate that across a multi-year civil engineering project. The cumulative savings, they are massive.
Now, to be completely objective here, we have to talk about the battery life. During heavy digging and loading, the EC230 ran for about 6 to 7 hours on a single full charge. For a standard 8-hour construction shift, that leaves a slight gap. But the operational fix was incredibly simple. They just plugged the machine in during the operator's lunch break. That quick top-up easily pushed the machine through the full 8-hour shift without missing a single beat. It's just a minor logistical adjustment for a major, major gain.
Section 5. A better operator experience, health and safety.
Let's step away from the spreadsheets for a moment and look at the human element, because this is so important. The transition to electric equipment radically changes the day-to-day experience for the actual people sitting in the cab, as well as the surrounding community. When we directly contrast a traditional diesel excavator with the electric EC230, the differences are literally night and day. Instead of sitting in a cloud of exhaust fumes, operators breathe clean, zero-tailpipe air. Instead of enduring that constant bone-rattling vibration of a heavy diesel engine, the electric motor provides remarkably smooth operation. And the noise reduction? It's incredible. It creates a far less exhausting working environment for the crew, and importantly, for urban projects like the one in Los Angeles, it drastically reduces construction noise for the surrounding neighborhoods. Operators during the pilot gave it highly favorable feedback, specifically praising its ease of use and its capacity.
Mason Ford, the Director of Sustainability and Equipment Services for Skanska USA Civil, summed up this sentiment perfectly. He said, "Aligned with our commitment to a cleaner future, the successful completion of this pilot program represents a significant stride forward for the entire industry." Skanska clearly views this specific pilot not just as a one-off experiment, but as a genuine catalyst for the wider evolution and adoption of lower emission practices across civil construction.
Section 6. The future of heavy machinery, beyond the pilot.
Zooming out from the LA pilot, it's absolutely clear this technology is here to stay. But to understand the future of heavy machinery, we have to look at the broader implications for the global construction industry and what is actually making this shift economically viable right now. Now, what's really interesting about this slide is the dramatic downward trend in the price of electric machine lithium battery packs from 2010 to 2023. For the absolute largest heavy vehicles, the ones weighing over 1,000 tons, the battery packs required are still too enormous and expensive to be viable. But because of this massive plunge in lithium battery prices, mid-sized equipment like the 20-ton EC230 is hitting the commercial sweet spot right now. And having these machines available opens up entirely new operational playbooks for construction firms. I mean, think about it. Because there are no exhaust fumes, you can run these excavators indoors without needing massive, expensive, extra ventilation systems. Because they're quiet, you can operate them in noise-sensitive urban areas, or during unsociable nighttime hours when diesel machines would totally violate noise ordinances. They are perfectly suited for strictly regulated low-carbon zones. But most importantly, they are the key tool that will allow industry leaders like Skanska to actually achieve that aggressive goal of a 70% carbon reduction by 2030.
The technology is proven.
The emissions drop is massive. The cost savings are very real, and the operator experience is vastly superior. Europe is already paving the way, but as we saw with the LA pilot, the equipment works just as well on American soil. So we leave you with this to ponder. The tools for a sustainable construction industry exist today, but will American construction sites adapt fast enough to actually lead this fossil-free revolution, or will they be left playing catch-up? Thanks for joining us for this explainer. We'll catch you next time.